Okay, so we're going to talk a little bit about Module 2, Lesson 4 in this video. This is a lesson where we talk about exponents and various rules that we can use to simplify exponential expressions. Before we get into that, just a quick review of what an exponent is. An exponent is a way to write repeated multiplication. So if we have something like this negative 5 squared, what this is telling me to do is it's telling me to do negative 5 times negative 5 a total of 2 times. That exponent up there tells me how many times I'm going to multiply these things together. And so for this one, this would be negative 5 times negative 5 or positive 25. The second problem over here, the important thing to note on this, and the reason why I bring this up is because it is something that's commonly missed. The exponent is only on the 5 here. It's only applied to that piece. This negative is its own separate little piece. So if we're going to use this rule to simplify this, 5 squared is 5 times 5, and then that negative is just hanging out as its own separate piece, and we just kind of bring it down in the front here. So 5 times 5 is 25, and we can continue to bring that negative sign on down. So exponents are used to represent repeated multiplications, and we really want to pay attention to whether the negative is part of our base or not. And so you want to pay attention to the difference between these two problems. Okay, so the bulk of what this lesson is really about, though, is about simplifying problems like this where we have exponents in them. So what I see here when I look at this problem is two exponential expressions. The x to the 7th is the first one, the x to the 6th is the second one, and they're multiplied together, okay? And so we need to be able to simplify these, and we have a rule that we can use for these, and it's called the product rule for exponents. And what it says is that if we have two exponential expressions that are multiplied together like this, we can combine those by adding the exponent. So our base is not going to change. Our base is still going to be an x there, and we're just going to add the 7 and the 6 up top there to get our new exponent. So pretty straightforward to simplify these if you know the rule. That's going to be kind of the key. And I would suggest maybe going into your book and finding, there's a nice list of exponent rules. If you can print that out and have that as a reference, it's going to be very helpful for this, because there are several of these exponent rules that we're going to need for the next exam. Okay. Similarly, we could have a problem like this where we have a couple of exponential expressions that are divided. Okay, if we have a problem like that, we're going to use our rule called the quotient rule for exponents. Looks like this. Okay, if we have the same base on an exponential expression in the top and bottom of a fraction like this, we can simplify this by subtracting those. And don't worry too much about that. Something that's got to be there to be mathematically correct. But we're just going to subtract those exponents in order to simplify. Okay, so this one, again, pretty straightforward to simplify if we know the rule. We're just going to subtract those exponents. And so my quotient here is going to be y to the 5th. We're just going to subtract the top minus bottom, and we're going to simplify from there. Okay, so the next type of problem that we'll need to be able to deal with is one like this. We call this a power to a power. I have a power on the inside of my parenthesis with a second power on the outside. Okay, example of that's going to look like this kind of in general. And the way that we're going to deal with that is we're just going to multiply those powers together. Okay, so for this one, it's just going to simplify. 5 times 3 is going to give me my new power of 15. So again, these rules are not hard to execute. What's hard is that there are several of them, and we need to use them enough times to start to get comfortable with when do I do what. Okay, so hopefully that makes sense. Okay, so this will be our first problem where we need to use a couple of rules kind of in combination to simplify it. The first thing that we need to do here is when we have a parenthesis like this with a couple of things that are multiplied together inside of them and a power on the outside, we need to be able to deal with that. And we do have another rule for that. It says that if we have two things that are multiplied together with a power on the outside, we're just going to take that power, we're going to move it in, and we're going to apply it to each of those factors inside of our parenthesis. Okay, so that's going to be our first step to simplifying this problem. We're going to take this exponent of 4. We're going to move it in. We're going to apply it to each of our pieces inside of the parenthesis. Whoops. Okay, and then we can simplify from here. That 3 to the 4th, well, that's just something that you can either evaluate with your calculator or, 3 times 3 times 3 times. It's not 12, so don't make that mistake. 3 to the 4th is 3 times 3 times 3 times 3. Work that out. You'll get an 81 over there. And then y to the 7th to the 4th, this is another example of the problem like we just did in the last example. We have a power to a power. When we have a power to a power, our rules say to multiply those powers together. It's going to be my new exponent of 28 up there. Okay, so this is an example of a problem where we'll have to use a couple of rules at the same time. We just wanted, and we'll definitely have to deal with some problems like that as we go through this lesson. Okay, so the next thing that we'll see in this lesson are exponential expressions where our exponent is 0. Okay, and very easy to deal with if you've done this. Again, a lot of these rules are not complicated to use, but there are a lot of them. So this will be a lesson that you have to practice quite a bit to know when to use which exponent rule. But when you have something to the 0 power, okay, it is always equal to 1. It doesn't matter what the value of our base is, I guess, as long as the base is not 0. More complicated there, but in general, if your base is not 0, you have an exponent of 0, this is equal to 1 every time. So it doesn't matter that this has a base of 8. 8 to the 0 is always equal to 1. Okay, you do need to be a little careful. You might have a problem like this, like -5 to the 0, and a lot of people will be like, oh yeah, it's just got to be 1, right? Well, no, it doesn't. You got to pay attention to what the exponent is actually on. In this case, the 5 is to the 0 power, and that negative sign out front is kind of its own little separate piece there. So 5 to the 0 is 1, and then that negative out front kind of comes over. And so anything to the 0 power is 1 is true. You just want to make sure you're only applying the 0 power where it should be applied. In this case, it's applied to that 5. And so -1 would be our simplified form there. And finally, we can have even more things. Like in this case, we got a couple of factors, 5 times x, both inside the parentheses to the 0 power. Doesn't matter because anything to the 0 power, regardless of as long as x is not equal to 0, this whole thing is equal to 1. Okay, that's what our rule says. The rule says that anything to the 0 power, as long as it's not equal to 0, is 1. Okay, so even with more than one factor in there, we're all right. Okay, so let's finish up this talk by looking at one more problem where we have to use a couple of rules in combination again. So for this one, the first thing that jumps out at me is the parenthesis across the top. We need to be able to deal with that. And we have a rule that says that we have a parenthesis like this with a couple of factors inside of it, an exponent on the outside. We're going to apply that to each of our factors inside. So we can kind of apply our third power to each of those factors inside that parenthesis. Okay, then we're just going to kind of work this out. 3 to the third, that's something that you can put in your calculator, or just think of 3 times 3 times 3. That's going to be a 27. Okay, and then here, x to the second to the third power on this second piece, our rules say to multiply those powers. So 2 times 3 is going to make my new power a 6. Okay, and now I can clean this up a little more by noticing I've got these pieces here with the same base that are divided, x to the 6th divided by x to the 4th. And our rules say when we have division like this to subtract our exponents. So x to the 4th divided by x to the 5th is the same as x to the 6th minus 4, or x squared. Okay, so we had to use a couple of, in fact, 3 separate rules there in that one problem. So we want to be comfortable with these because we're going to have to use them, multiple rules in the same problem from time to time. Last thing I wanted to talk about in this lesson is just a quick reminder. When we have a problem like this, x to the 7th over x, we have that bottom term that doesn't have an implied exponent on it. The implied exponent up top is a 1. Okay, so if we're going to simplify this, because they're divided, we know we're going to subtract those exponents. So this is going to be x 7 minus 1, or 6 there for my new exponent. So if you have no written exponent on your variable, the implied exponent is a 1. So be ready for that. Okay, so hopefully that's helpful. Please don't hesitate to let me know if you have any questions.